Hello class, welcome to 1430, section 2.4 limits. I've got 4 or 5 problems here. So we can evaluate limits by looking at graphs, or we can find limits algebraically. So my first 2 examples will be looking at graphs. So here's y equals some function of x. Notice at x equals 2, we have a hole in the graph. So at x equals 2, we have a hole in the graph. Let me turn off this light again. 1 second. Okay, no glare. So at x equals 2, we have a hole in the graph. So this implies if, in algebra, if I asked you, what does f of 2 equal? F of 2, that's how we write it. So when I input 2 into the function, what is the output? We do not get a real number because a hole in the graph indicates that we have no value for x equals 2. So what we say is f of 2 does not exist. You'll see this sometimes. DNE does not exist. So you can either write it out or just write DNE. In algebra, we say f of 2 does not exist. So if it doesn't exist, that implies that x equals 2 is not in the domain of the function. X equals 2 is not in the domain of the function. Because to be in the domain, you have to be an allowable input. But 2 is not an allowable input for x, because there's a hole in the graph at x equals 2. Okay, so limits are really usually the first topic in calculus. So even though f of 2 does not exist, what is the limit as x approaches 2 of f of x? So this is the notation. What is the limit as x approaches 2? That arrow means approaches. What is the limit as x approaches 2 of our function of x? In other words, i.e., id est, what is the intended height of the graph as x approaches 2? So limits talk about intended heights of the graph. And height means the y-coordinate. Notice that when you look at this graph, isn't the y vertical? So these are the heights. So as x gets closer and closer to 2, it looks like the intended height is 4. And in fact, that's going to be the answer to our limit question. So the limit as x approaches 2 of f of x, we're going to see that answer is going to be 4. But let's show more why that's the answer. So to really truly understand what is the limit as x approaches 2 for this function, I want to approach 2 from the right-hand side, get closer and closer to 2, and look at these outputs for y. Because limits are all about as you approach some number x, what is y approaching? So the limit will tell you what y is approaching as x is approaching some fixed number, in this case 2. So it looks like when x is 3, y is going to be higher than 4. But when x is 2.1, it's going to get closer to 4. And I can get as close to 2 as I want. Like if I let x equal 2.0001, then I'm going to get really, really close to the output of 4. And if I let x equal 2.000001, I'm going to get even closer to 4. Because I can get as close to 4 as I want as I approach 2 from the right-hand side of 2. So I'm going through 4, 3, 2.3, 2.1, 2.001, whatever. You're going to see that the outputs get closer and closer to 4. And likewise, as I approach 2 from the left-hand side, like when x is maybe 0.5, y is 0. But when x is 1, y is going to be maybe, 2. And as I get closer and closer to 2 from the left-hand side of 2, the outputs get closer and closer to 4. So if I let x equal 1.9999, y is going to be very close to 4. So the intended height is 4. So the limit as x approaches 2 of f of x is going to equal 4. So I talked about approaching 2 from the right-hand side and the left-hand side. So there's notation for that. So whenever you're asked to find a limit as x approaches 2, it's nice to look at the left and right-hand limits. So we must look at, this is called the left-hand limit because of this minus sign. So the limit as x approaches 2 from the left, that's called the left-hand limit of f of x. You want to see what that equals? And you also want to look at the right-hand limit. which is denoted with the plus sign, the limit as x approaches 2 from the right of f of x. Now, if the left-hand limit is the same as the right-hand limit, then we say the limit is going to be that answer. So, what was the limit as x approaches 2 from the left of f of x? We said the answer was 4. And also, the limit as x approaches 2 from the right of f of x, we said the answer was 4. So because the left-hand limit is equal to the right-hand limit, then we say that the general limit, which is denoted like this, the limit as x approaches 2, without a plus or a minus. This is the general limit. So the general limit, and limits need inputs. I'm going to write f of x. That will also equal 4. So if the left-hand limit equals some real number and the right-hand limit equals the same real number, then the general limit is going to equal that limit. Another name for general limit is the two-handed limit, the right and left. So the two-handed limit, or the general limit, is equal to 4. Okay, so we're done with that first problem. We found the limit of this function as x approached the fixed number 2. Now, I can put a little variation of this problem. I'm going to put a solid dot right here on the graph. This is the graph. And let's say this y value is 1. So this is now a solid dot. So suddenly when x is equal to 2, we have y is equal to 1. So let's go through these two questions again based on this new problem where we have a solid dot at x equals 2. Notice this is a function. It passes the vertical line test. This hole means it's not a point, but when I draw this vertical line x equals 2, I hit the graph exactly once at this point here. So here we go. Let's ask these two questions. Do you think f of 2 is still going to be does not exist with this new problem? And the answer is no. Here's what's going to happen. So for the algebra question, I'm going to write f of 2 is now equal to 1. 2 is now in the domain of this function because when x is 2, y is 1. This point is on the graph. It's kind of a weird looking problem. Okay, and now let's ask the limit question. What is the limit? What is the limit as x approaches 2? Do you think the answer is still going to be 4? Is the limit as x approaches 2 still going to be 4? And the answer is yes, because as I approach 2, from the right-hand side, getting closer and closer to 2, y is getting closer and closer to 4. Remember, limits are all about as you approach the number, not when it equals the number. So when it equals 2, that's algebra. The answer is going to be 1 in this case. But as I approach 2 from the left-hand side, the values of y get closer and closer to 4 as well. So even for this problem, I'm going to say the limit as x approaches 2 of our function is going to equal 4. So limits describe the behavior of the graph as x approaches some number. You can get as close as you want to that number, but don't equal the number for limits. And as you get closer and closer to that fixed number, do the y values approach exactly one number from the left-hand side and the right-hand side? If you do, then the answer is the limit exists, and it is going to be that number. Okay, let's go on to a second problem. So we did number 1, and now we go to number 2. So this is a different looking graph. So this is called a jump discontinuity, because at x equals 1, we have a hole here, but a solid dot there. So let's ask the algebra question first. What is f of 1 for this graph? What do you think? When I input 1, what do I output? And the answer is that solid dot 5. So f of 1 is equal to 5. And now let's ask the calculus question. What is the general limit as x approaches 1 of f of x? What is that going to equal? Do you think it's going to be 5? Let's find out. So to find this general limit, you want to look at the left-hand limit and right-hand limit. So if I look at the left-hand limit, that means as I'm looking from the left-hand side of x equals 1. So when x is equal to like a -1 and 0 and 0.9 and 0.99, what is the output for y? What is the value of y? Well, it's getting closer and closer to this value of 2. So let me write that down. The limit as x approaches 1 from the left of f of x is equal to 2. Let's go back to make sure that looks good to you. The limit as x approaches 1 from the left, so that means 1 minus. Aren't the values getting closer and closer to 2? Okay, but what happens when I approach 1 from the right-hand side, meaning when x is 3, when x is 2, when x is 1.5? Like when x is 3, y looks like maybe it's 6. But as I get closer and closer to 1, I'm getting closer and closer to 5 for y. So the limit as x approaches 1 from the right, the answer is going to be 5. And here's how we denote that. The limit as x approaches 1 from the right of f of x is equal to 5, we said. 5. So notice the left-hand limit is 2, but the right-hand limit is 5. So whenever the left-hand limit does not equal the right-hand limit, then we say the general limit does not exist. The two-sided limit does not exist. So let's write that down for my final answer. The limit as x approaches 1 for this function f of x does not exist, because the left-hand limit is different from the right-hand limit. And for the limit to exist, that means as you approach from the left or the right, the output for y is going to get closer and closer to the same real number. Okay, and the next two problems are going to go quicker. The algebra problems here. Fine, this is a calculus problem because it has the word limit, but we're looking at an algebraic expression here. So the easiest way to evaluate a limit is just to simply plug in the x value. So notice if x is 3, isn't 2 times 3 6 plus 1 is 7? If you get a real number just by plugging in the x value, then that's the limit. So I'm just going to write equals 7. That limit equals 7 because we're allowed to just, whenever you have an algebraic expression, the easiest way to find the limit is just to plug in the arrow number. Here the arrow number is 3. And if you get a real number answer, that's your answer. So if I were to graph this question at x equals 3, the graph would be continuous. So the limit as x approaches 3 would be the y value 7. Because as you approach 3 from the left or the right on the graph of this line, y would be 7. Okay, this one's a little bit more tricky because, here again I see a limit of some algebraic expression. This is some function of x. And my first instinct is to plug in the arrow number. This is called direct substitution. So the easiest way to find a limit is by direct substitution. When it works, usually it will not work, as in this case. Notice if I input 2, I'm going to get 2 squared is 4 minus 4 is 0. It's okay to have 0 on the top. But look on the denominator. When x is 2, I'm dividing by 0 because 2 minus 2 is 0. Whenever you divide by 0, that is not a real number. So we got to find the limit another technique. And I'm going to do the technique of factoring. So this is going to equal the limit. It's nice to have good form. Rewrite the word limit as x approaches 2. And now x squared minus 4 factors. So this is a technique that we often use to evaluate limits when applicable. So I'm going to write x plus 2, x minus 2 over the x minus 2. And now look at this key cancellation. I'm allowed to cancel these factors because we're doing the limit as x approaches 2, not equal to 2. So this is just going to be another name for 1 as long as x does not equal 2. So cancel the x minus 2 with the x minus 2. And now this is going to equal the limit as x approaches 2 of simply x plus 2. If you want, you can put parentheses. They're optional. So now, thanks to the canceling, I can do a direct substitution to get my final answer. When I input 2 into this expression, 2 plus 2 is 4. So that's my final answer to the limit problem. So that was interesting. And we are done. So hope everyone is doing well. And we'll see you next time. And I'll close like this. Boom. Or boom. Okay. Bye-bye.